Hi everyone, welcome back again to Advanced Function MHF4U1. In this lesson number 5, we are going to learn about inverse relations or inverse functions. Our learning goal is to understand the properties of inverse function. First, what is an inverse function? Now, all you need to do is from a function, you are going to switch x and y for all the order pair to get an inverse function. So any function f has an inverse relation, or any inverse is represented with exponent of -1. When we read it, we never read it as f exponent -1. We read it as inverse function. So this is my original function, which is xy, and the inverse function will be represented as f inverse, and the points are going to be switched like this. Now, graphically, inverse functions are they're symmetrical about the line of y is equal to x, a straight line. So as you can see, if I were to fold this paper or this page through the y is equal to x straight line, I'm going to get an inverse. So this is my function r, and this is my inverse relation r. And they are symmetrical through the straight line. What about domain and range for inverse? They're exactly the same, except the range of the relation becomes the domain, and vice versa. So we have, let's say, a function of domain and range. The inverse function, domain, becomes the range of the function, and the range is by the domain of the original function. So let's try the first question. Graph the inverse relation, state domain and range. So when you're given a graph, especially a shape, identify the key points. So this is -2, 1, 2, 3, 4, 4. This is -1, 1. And this point is going to be 2, 3, 4, -4, -1. Now what I'm going to do is I'm going to switch the points, x and y. So -4, -1 becomes -1 and -4. So this point comes over here, -1, -4. And this point, it becomes 1 and -1. 1, -1. We're switching it. And this point is 4, -2. And it's over here, 4, -2. And I'm going to connect the points. Okay, it's a little bit off. So as you can see, are they symmetrical through the y is equal to x? Yes, they are. They are exactly symmetrical through y is equal to x. So the domain and range, so the domain for the original, let's say this is f at x domain. As you can see, x can be any real number such that it's in between -4 and -1. And range, y can be any real number such that it's in between -1 and 4. So the inverse relation of this is going to be the domain is going to take over the range of my original. So x can be any real number such that it's in between -1 and 4. Do you see that? It's being switched. And then the range is going to be y can be any real number such that it's in between -4 and -1. Now there is a way to represent inverse function algebraically. So first, you want to write the original function in a function notation, f of x, into y. So change that into y. And what we're going to do, we're going to switch it. Switch x and y. And we're going to solve for y. And once you are done isolating y, you're going to replace y with f inverse. Okay, so these are the 4 steps to remember finding inverse of a function. So let's find the inverse of a function algebraically. First step, change f of x into y. Then we're going to switch. X is equal to 1 minus 2, y minus 3. Now we are going to isolate for y. So let's move 1 to the other side. So x minus 1, -2, y minus 3. Divide both sides by -2. So x minus 1 over -2 is square root y minus 3. So we are going to, opposite of square root is we're going to square it. Square both sides. Therefore, the square root and the square cancels out. So we have x minus 1 over -2 square is equal to y minus 3. And then y is equal to x minus 1, -2 squared, plus 3. Okay, so this negative becomes positive, so you can just delete this. And this is going to be the inverse of a function algebraically. So we have to replace it with f of inverse is equal to x minus 1 squared plus 3, like that. Now, so the horizontal test is used to identify if my inverse is going to be a function or not. So if it's one-to-one function, it only touches only one point for doing horizontal lines. So I have a horizontal line, a ruler, and I'm going to go down. Okay, so as I go down, it's touching one point at a time. So this is an asymptote. So it won't touch. It's going to slowly approach it, but it's not going to touch it. So yes, the inverse of this reciprocal function is going to be a function. But this, on the other hand, it touches 2 points on this horizontal line. So the inverse of this absolute function, it's not a function. Okay, so it does not pass the horizontal line test.